Hey everyone, today we're going to be talking about classifying matter, or really what are some different ways that we can distinguish between some different types of matter, particularly pure substances and different types of mixtures. Being able to do this is ultimately going to help us be able to separate different types of mixtures in the lab. So how we kind of are going to break this down. So we have two main categories. We can have a pure substance or a mixture, and there's a couple of categories underneath each of these. So a pure substance can either be an element or a compound, and then a mixture can be either a homogeneous mixture or a heterogeneous mixture. And we're going to talk briefly about what each of these things are and give some examples in these notes. So a pure substance, this is a substance in which if I take a sample of that substance, every single sample that I would take would have the exact same properties, both physically and chemically, as the sample before it. So an example here, if I take a pinch of salt, each pinch of salt is going to have the same physical and chemical properties. If I take a sample of gold, each sample of gold is going to have the exact same physical and chemical properties. It's also important to note here that pure substances cannot be broken down or separated physically. So in order to separate a pure substance, I would have to perform a chemical reaction in order to make that separation happen. So here are some examples of pure substances. So pure substances can be either elements or they can be compounds. So if I'm looking at a diagram on a microscopic scale, if I can actually see the atoms, elements, these are either going to be single atoms or they can be atoms of the same kind that are bonded together. So an example of an element that's a single atom might be gold. So I would have single atoms of gold kind of all next to each other. I just kind of drew them as circles here. An example of an element that would have atoms of the same kind bonded together would be oxygen. So with oxygen, we actually see two oxygen atoms bonded together to form O2. So if I saw a microscopic picture of that, it might look like two circles bonded together. So while these look slightly different, both of these would be considered elements. This is just an element that's a single atom. This is an element that's two or more of the same type of atom bonded together. That's going to be different from a compound because with a compound, here we're going to have atoms of different kinds that are bonded together. So an example of this might be water. So I would have one oxygen atom bonded with two hydrogen atoms. So here I can see that there's different atoms, but those atoms are bonded to one another. Here the important key is that they're bonded together. So this is still a pure substance because each one of these molecules looks the same. So each sample of this water I would take would have the same physical and chemical properties of any sample that I took before it. So because they're bonded together. So that's really important distinguishing characteristic. Okay, so here we can see some different pictures below, so we can identify these as either elements or compounds. So my picture on the left, I see single dots. They all are the same, so this is going to be an element. My picture in the middle, I see two dots bonded together, but each one of those dots are open circles. That's going to, and they're the same color. So they're going to indicate to me that it's two of the same kind of atom bonded together. So this is also an element. And then to the right here, I see two open circles bonded with one filled-in circle, but all of them look the same as I look through all of these. So because they're all the same molecule, this is still a pure substance, but in this case, this is going to be a compound. Okay. If something isn't a pure substance, then it is a mixture. So a mixture is when we have two or more pure substances that combine together, but they don't chemically bond. So here the important distinguishing point here is that they don't bond chemically. We just see atoms of different kinds or molecules of different kinds sitting next to each other, but the molecules stay separated. Mixtures can be physically separated. So my pure substances cannot be physically separated. separated, my mixtures can be physically separated. And based on kind of what kind of mixture I have, I can separate them using filtration, evaporation, distillation, magnetism. We're going to talk about these ones later this week. Some examples of mixtures would be sand. So I have grains of sand that are different from one another together in one container, or even cereal. I have different types of pieces of cereal mixed with milk, or salsa. I have those different things mixed together, okay? Or even salt water would be a good example of a mixture as well, because I have salt mixed with water. They do not chemically bond. They just kind of exist next to each other. I can separate mixtures into two types, so homogeneous versus heterogeneous, and our prefixes here are important. Homo in science is going to mean same, hetero means different. So a homogeneous mixture is going to look the same, or it's going to look uniform throughout the substance. So it doesn't matter where I look, it's going to look uniform throughout. So examples here, we have milk, vanilla yogurt, Gatorade, salt water. All of these would be example of homogeneous mixtures, because anywhere I look in these substances is going to look the same no matter what. But they are mixtures still, because we have molecules that are separate from one another, existing alongside of each other. Heterogeneous mixtures. These are going to typically be composed of larger pieces that can be easily separated by physical means, and they're not going to look the same. They're not going to look uniform throughout. So here, fruit salad, vegetable soup, salsa, these are examples of heterogeneous mixtures. So if I look at this, if I look here, I see a carrot. If I look over here, I see a what is this, a onion. Over here, I see a green whatever. Over here, I see some broth. So it's going to look different. It does not look uniform throughout. We can see that as well with salsa. And these are going to be things that are very easily separated by physical means. It might be more difficult to separate salt from water than it is to separate all the onions out of a salsa, for example. Alloys are a very common type of mixture that we see as well, particularly in chemistry, and we really see these a lot in your everyday life, more than you, I think, even realize. So an alloy, this is a mixture of two or more metals, the key word here being mixture. So this is a mixture of two or more metals that have different properties from one another, but when they combine together, they have kind of different properties than either of the metals they started out as. The metals here are not chemically bonded, so these would be considered homogeneous mixtures, or mixtures that look uniform, but we don't see big chunks, but they're not pure substances because there's not chemical bonding that's happening. So some common examples we see in our everyday life, we have brass. Brass is actually a mixture of copper and zinc. Bronze is a mixture of copper, tin, and aluminum. And sterling silver is a mixture of silver and copper. We really may create these alloys because they're essentially going to make the metal better in some way, or add some additional properties that we didn't have before. So they might make it more durable. With sterling silver, it makes it so that we make a lot of jewelry out of this because it won't tarnish like silver and copper will. So we see those sorts of properties as well. This diagram is just going to outline what we talked about. So we have pure substances versus mixtures, some different kinds, and then some pictures for you, some different kinds, and then some pictures for you. It would probably be a good idea in your notes to maybe make a diagram similar to this and list some examples for yourself.